So in this video, we'll be learning about evaluating and simplifying positive and negative exponents. Yesterday, we worked with some exponent laws. Today, we will be works with some more. So the first one is x cube. How can we write x cube? So we can write it as x multiplied by x multiplied by x. Similarly, we can write, if you have another variable, it's a times a times a. Now let's see these exponents. A to the power 2 and then it's raised to another one, which is 3. So this means this is my exponent and this one is raised to the power 3. So I can multiply a square 3 times. So if we use the exponent laws, the bases are same, so I can add the exponents. So a2 plus 2 plus 2, which gives me a to the power 6. Similarly, in the second one, the base in here is a square and it's raised to the power 5. So I can multiply a square 5 times. A square times a square times a square times a square. And again, if I apply the exponent laws, I add all the powers. 2 plus 2 plus 2 plus 2, and this gives me a to the power 10. Now, if we closely look at these exponents in here and compare it to the ones at the back, so 3 and 2, and the final exponent is 6, 2 and 5, and the final exponent is 10. So, in this gives us a second law, which states raising a power to the exponent, raising a power to exponent. So in this case, if I have a power which is raised to another exponent, we just simply multiply both these exponents. So the example in here is this one. We now just multiply these two exponents. Multiply exponents. So a 2 multiplied by 5, which becomes a to the power 10. So that's our first concept in here, raising a power to the exponent. Let's do some practice in here. Now again, I have the base and I have the exponent, which is 5. Now this means this 5 is with b square and the 5 is with a cube also. So I can write a 3 multiplied by 5 because we multiply the exponent, and b 2 multiplied by 5, which gives me a to the power 15 and b to the power 10. Again, I'm going to do the same thing, but in this case I have a coefficient which is 2, so the exponent also applies to this coefficient. So this becomes 2 cube and multiply by a squared to the power 3. 2 cube becomes 8, and when we multiply 2 and 3 it is 6. So that's our answer in here. Let's simplify next. Again, I'm going to distribute the exponent to all which are there inside the bracket. So x 2 times 4, y 3 times 4, and z 7 times 4. So x to the power 8, y to the power 12, and z to the power 28. So it's just raising an exponent, raising a power to an exponent. Now let's see if we have a negative sign in the picture. So I have a negative 3 here. The basic concept, this 5 will apply to all the things inside the bracket. So negative 3 to the power 5, a 4 times 5, and b 7 times 5. So negative 3 to the power 5, we can write this as negative 3 times negative 3 times negative 3. And you can simplify. So 4 times 5 is 20 and 7 times 5 is 35. And when you simplify it using calculator, you get negative 243, a to the power 20 and b to the power 35. So that's how we can simplify using this law, which is raising a power to the exponent. Now let's move on to the next, which is raising a quotient to the exponent. Now we've done the multiplication part and we will do the division one. Now you can see in this case, bases are different. The one which we did yesterday, the bases were same in that case. So if the bases are different and it's raised to another exponent, so we'll give this exponent to both the numerator and denominator. And this means a is 3 times 4 and b squared times 4, which becomes 8 to the power 12 and b to the power 8. So that's another law of exponent, which is raising a quotient to an exponent. So if I have a quotient where the bases are same or different and it's raised, we give this to both the numerator and denominator. Let's use this concept or this law and simplify a few examples. So I have an exponent which is 3 up on the top, and I'm going to simplify the following expression. Let's just distribute the exponents to all the terms inside the bracket, which gives me 4 cube x, 9 times 3 is 27, y, 8 times 3 is 24, divided by 7 cube, w cube, and z 3 times 5 is 15. Now 4 cube is 64, x 27, y 24, divided by 7 cube is 243, w cube, and z 50. Simply I just distributed, gave the exponent to all the terms inside the bracket and solved it. Let's do the same thing with the next one. Now in here, there are a few ways to do this. I can either simplify the terms which are inside the bracket. For example, this 7 and this 49 can be simplified further. 7 times 1 is 7 and 7 times 7 is 49. So what I'm left with is 1 over 7 a to the power x over a to the power 4 raised to the power 3. Now again, I'm going to simplify this further inside the bracket. So this is the same basis, a and a. So 1 over 7 as it is, a, x, since it's division, so I'm going to subtract the exponents to the power 3. We can also write it a, x minus 4 over 7 to the power 3. Now we can distribute the exponents. Now this 3 will be multiplied with 4 also and x also. A, 3x minus 12 over 7 cube, which is a, 3x minus 12 over 343. So that gives us the solution for this expression. Okay, so now we come on to the next thing, which are negative exponents. Now in negative exponents, let's find a pattern first, and then we talk about them. If I say 2 to the power 5, what do you think? What is 2 to the power 5? It means 2 multiplied by itself 5 times, which is 32. Now you reduce the exponent by 1. So if I do that, it is 2 to the power 4. Now I've reduced it by 1. 2 to the power 4 is 16. Again by 1, 2 cube. 2 cube is 8. 2 square, that is 4. 2 to the power 1 is 2. 2 to the power 0. Anything to the power 0 is always 1. Now let's look at the pattern. If I take this 32 and divide it by the base, which is 2, I get 16. And this 16 is the answer for the next expression. Now if I take 16 and divide by the base, which is 2, I get 8, which is the next value. If I take 8 and divide by the base, I get 4, which is the next value. 4 divided by 2 is 2. 2 divided by 2 is 1. So we see we are following in a pattern. So let's again reduce by 1. So if we reduce by 1, we get negative 1. Now what we will do, take this 1 and then we divide it by the base, which is 2. to find out the next value, and this can be written as 1 over 2. So that's 1 over 2. Now again reduce it by 1, so it becomes 2 to the power 2. Now we take this answer, that's 1 over 2, and we divide it by 2. So when we divide, let's make this as a fraction over 1. So when we divide the two fractions, we take the first fraction, we change the division sign into multiplication, and we flip the second fractions, which becomes 1 over 2. And this is 1 over 4. So it means 2 to the power negative 2 is 1 over 4. Now again, if I reduce 2 to the power minus 3, I take my 1 over 4 and divide it by 2. And when you do that, you get 1 over 8. So can you see a pattern going on here? So if in here, so 2 to the power minus 1 is 1 over 2. 2 to the power minus 2 is 1 over 4. We can also write this as 1 over 2 square. And we can also write it as 1 over 2 cube. Now see. 2 to the power minus 2. 2 to the power minus 3. So what's happening is, whenever we have negative exponent, for example 2 to the power minus 3, in order to make it positive, we bring that in the denominator. So 1 over 2 to the power 3, it becomes positive. So how can we write 2 to the power negative 9 as a positive exponent? We bring it in the denominator, 1 over 2 to the power 9. This is the law of the negative exponents. So whenever you have negative exponents, we always give our answers in the positive exponents. So whenever you have an expression in a negative exponent, you always write it as 1 over a to the power n, and it becomes positive. Let's work out some examples, practice this concept. Now I have 7 to the power negative 2. In order to make the negative exponent positive, I will do 1 over 7 squares. So this becomes 1 over 49. Now next, negative 5 negative 5 and 5 is raised to power negative 4. Now it's not in the bracket, so I can write it as negative 1 times 5 to the power 4, which will be negative 1, it's negative, times 1 over 5 to the power 4, which is 1 over, when you use that in your calculator, 625. Let's evaluate the next example and see if we can work it out. Now in this one, the bases are same and they are being multiplied. So we will add all the exponents. So 3 minus 3 plus 5 minus 6. So minus 3 and minus 6 gives us minus 9 plus 5, which is 3 to the power minus 4. And in order to make it positive, I'll do 1 over 3 to the power 4, which is 1 over 81. Let's work out the next one. I don't have the same basis in this one. Therefore, I cannot add or subtract the exponents. So I'm going to simplify it. But first, I'm going to make this negative exponent positive by writing 1 over 2 cube. 5 squared is 25. Now this becomes 1 over 8 multiplied by 25. Since it's 25 is just a number, to make it a fraction, I'm going to write over 1. And this is 25 over 8. So that's the solution for this expression. Okay, let's work on the next one. Evaluate 4 to the power negative 5 and 4 to the power 3. Bases are same. Do you change the negative exponent to positive immediately? So in this case, you can either change it, but since the bases are same, I'll first simplify the exponents to make this expression simpler. So 4 minus 5 plus 3, because they are multiplying, 4 to the power minus 2. Now it's much more easier to change it into a positive exponent, which is 1 over 4 square, which is 1 over 16. That becomes your answer, right? Now, you had all these negative exponents, and in order to make them positive, you bring them at the denominator. But what will happen the other way? Now, this is my negative exponent. Here, I have to make it positive. Simple thing, I'll bring it to the top in the numerator. 3 times 4 square. Right? Let's do one more. 8 times 3 to the power minus 2. Can you write it to the positive exponent? Yes. 8 over 1 times 1 over 3 square, which gives me 8 over 3 square. Since it's asking me to write this with the positive exponent quickly, so I'm going to leave it here and not simplify further, because this thing is asking me to leave my answer with the positive exponent. Let's work with some more examples. Negative exponents. Again, I have my expression with the negative exponent on the top. In order to make it positive, I'll bring it at the bottom. 1 over 2 multiplied by 3 to the power 4, which will be 1 over 2 times 81, and this gives us 1 over 162. One more example. The only negative exponent is this. So a to the power 4 and c to the power 3 stays up, and b comes at the bottom, and this becomes a positive exponent. Next one. Negative exponent is at the bottom. I'll take it to the top. 5 times 4 to the power 3, and when you plug that in your calculator, you get 320. Next, so first figure out the negative ones. This is negative, this is negative. So negative 3 and y square will stay on the top, and the other 2 comes at the bottom and becomes positive. What happens if both these numerators and denominators they are negative? We just flip them. 5 will go on the top and becomes positive. 6 will come at the bottom and becomes positive. Now since we have to evaluate, I'll give the final answer. 5 squared is 25, 6 cube is 216. Next one, negative exponent, and negative. Switch the places. Z will go on top. I have x squared already there, times z7. Now the base will not change. Base is minus 5. It stays minus 5 to the power 3 and y to the power 4. I hope this is clear. Let's practice more and work with some more examples so that you can get hang of it. Okay, simplify and leave the answers with the positive exponents. So I'm going to do the first one. Exponent is 4 outside. I'm going to distribute it first to all the terms inside. 5 to the power 4. A 3 times 4 is 12. B minus 6 times 4 is minus 24. And C 5 times 4 is 20. Now let's look at the negative terms. In this case, only this is negative. So 5 to the power 4 is 625. A to the power 12, C to the power 20 over B to the power 24. Because B was negative, so I switched its place and bring this thing to the bottom. And the next one. Same thing in here. First of all, I'm going to distribute the exponent to all the terms inside. So this becomes 2 to the power minus 1. A, negative 2 times negative 1 is positive 2. 2 times negative 1 is negative 2. That's one expression. Similarly, the same thing. 3 to the power minus 2. A, 3 times 2 is 6. B, negative 3 times negative 2 is negative 6. Now we are multiplying them and the bases are same. So we add the exponents. So 2 to the power negative 1 as it is times 3 to the power negative 2 as it is. A, 2 plus 6 is 8. B, minus 2 plus minus 6, it gives you minus 8. Now look at the negative terms in here. This one is negative, this one is, and this one is negative. So A to the power 8 will stay up, 2 to the power 1 in the bottom, times 3 to the power 2, times B to the power 8. And when you simplify that, this is 18, B to the power 8. There are various ways to do that, but I think the simplest one is this. First, you bring the outside exponent and multiply everything inside, and then you apply the other laws, right? Let's do the next one. Again, I'm going to do the same thing. Distribute the exponent. 5 to the power minus 3, a to the power minus 12 over a to the power 7, because the bracket is only with the numerator, right? Now bases are same. So 5 to the power minus 3, a minus 12 minus 7, which gives me a to the power minus 19. Now since both are negative, I'll bring them in the bottom. 1 to the power, 5 to the power 3, a to the power 19. And if you simplify further, 1 over 125, a 19. So that's your final answer. Let's go ahead and see if we have fractions with us. What happens when you have a fraction and the fraction is raised to a negative exponent? We simply take the reciprocal of the fraction, right? That's it. Take the reciprocal of the fraction to make the exponent positive. So this becomes 3 over 2. It will become positive. This will be 6 over 7 and make 1 positive. This will be 8 over 5 with the positive. This will be 6 over 7 with the positive 1. So take reciprocal of fraction to make exponent positive. That's it. Let's try this rule with these problems. So in here the exponent is negative and that's a fraction. So what I'm going to do is I'm flip the fraction. B to the power 4 over a to the power 3, positive 1, which can be written as b to the power 4 over a to the power 3. Next thing, same. I'm going to make the exponent positive. So take the reciprocal. 2y 7, 3x 5, and 2. Now I'm going to give this exponent to everything inside the bracket. So 2 square y 14, 3 square x 10. So 2 square is 4, y 14, 9, x 10. Now we're going to do the last two examples, which are a bit complicated to look, but if we follow all the rules and all the steps, these are not that bad. First of all, it's negative. I'm going to make it positive by flipping it. So this is 3x to the power minus 5 over y square minus 4. Since we are only making the outside exponent positive, so inside the negatives will stay same. Now distribute the exponent. 3 to the power 4 x minus 5 times 4 minus 20. Now y 2 times 4 is 8. Minus 4 to the power 4 x minus 2 times 4 minus 8 and y minus 12. Let's just simplify them. Bases are same. So 3 to the power 4 gives us 81. Now x minus 20 minus, since it's division, minus 8. and y 8 minus minus 12 over 256. Now 81x minus 20 minus minus becomes plus. So this is minus 12 and y to the power 20 negative minus minus becomes plus 256. Now look here, we have only one negative exponent. This will only switch the place. 81 y to the power 20 over 256 x to the power 12. So that's the final answer. All the exponents are positive now. Let's try the same thing with the next example. Again, I'm going to make this exponent positive first. So we flip it. 5a square b minus 2, 6, and this is 3. And the second one stays same. Let's distribute the exponent. Now 5 cube, a to the power 6, b to the power minus 6, 6 cube, a to the power minus 3, and b to the power 3. Now we'll multiply it. 3 square, which is 9, a to the power 6, b to the power minus 4, 25 square, a to the power minus 2, and b to the power 4. So what we did, we just multiplied these. Right? Now let's simplify further. 5 cube is 125 over 216. A 6 minus minus 3. B minus 6 minus 3. That's one bracket. And then we have 9 over 625. Now A 6 minus minus 2 and B minus 4 minus 4. Now 125 and 625, we can cancel it out. 125 times 1, 125 times 5, 9 times 1, 9 times 24. So what we are left with, 24 times 5 is 1 over 120. A 9, B minus 9 times A to the power 8 and b to the power minus 8. So 1 over 120 as it is. These are same bases. So A 9 plus 8, 15, minus 9 minus 8, minus 17. This is only the negative one. So we'll switch a to the power 15 over 120, b to the power 17. So that's it. I know they look a little bit difficult, but if you follow all the steps and all the laws, they are not so bad. Okay, and